All right, guys, this is kind of like a Cliff Notes guide to the beginning of basics of triangles, hoping to help you pull together what you learned or didn't learn from the self-discovery activity and to get some good notes down over what's true about a triangle. Some of this you already know, some of it's brand new. Please take notes over anything you don't already know. So this is organized in one way where it's the two columns. One side is going to be all about the sides of a triangle, and then the right side is all about the angles. So we're going to go through and talk sides first, then we'll go back over and hit on the angle business, okay? So let's start with equilateral, isosceles, and scalene. Basically, the idea here, folks, is just, do we have any matching sides? Okay, now if I give you a picture of a triangle and I give you a ruler, then you are more than welcome to measure it and to decide if anything matches. Now if you measure this triangle and you realize that two sides match, that would be how you denote it in geometry, that two sides match. You put these little congruency marks, like a little tick mark on it, and this tells your reader that those two match. Well, if two sides match, guess what? You're looking at an isosceles triangle. So isosceles is if two sides match. So what do you think it means if we end up with all three sides matching? Well, if it's all three sides, that would be equilateral. And something you might remember from the past about an equilateral triangle is that all the angles also match. That's going to be 60, 60, and 60. And something that I'd like to mention about isosceles, let me draw that same looking triangle here. And if we know these two are congruent, something else cool about an isosceles triangle is that the opposite angles down here are congruent. These are called the base angles, and not just because they're at the bottom, but the base angles meaning the two angles opposite the congruent sides, they are also congruent. So that's kind of cool. And then scalene just means that nobody matches. So once again, if you had a ruler, you could find that out. Or maybe maybe they're measured with congruency marks that don't match. So like this one has 1, this has 2, and this has 3. If they have a different number of little tick marks, it means they don't go together, therefore they don't match. So this would be your scalene, okay? So equilateral, isosceles, scalene. Now, what about the range of triangle side lengths? This one is a theorem. I'm not going to write it out all formal and theorem-y. I'm just going to kind of get to the nuts and bolts of it. What this says is that any two sides of a triangle need to add up and be bigger than the third side. Okay, and hopefully, otherwise the triangle is going to collapse on itself. So let me give you an example of what I'm talking about. Okay, a good triangle would be something like 4, 5, and 8. Okay, this is a good triangle because if I add any two sides, they are bigger than the third. 4 plus 5, is that bigger than 8? Yes, it is. Is 5 plus 8 bigger than 4? Yes, it is. Is 4 plus 8 bigger than 5? Yes, it is. This would be a good triangle. A bad triangle is something where that does not happen. So maybe I give you something like 2, 4, and 6. Okay? Now, if I take 2 plus 4, is that bigger than 6? The answer is no, it's equal to 6. But being equal is not good enough. These have to be bigger than the third side. And if they're not, it's a bad triangle. Okay? So what's going to be something that we do with this? Well, basically what you're going to be given is someone's going to be like, okay, so what if you know that two sides of your triangle are like 4 and 7, and then they want you to find the third side length. Find third side length. So if somebody asks you to do that, it's going to be a range of values. And that range of values can always be found, it's actually pretty easy, by adding and subtracting the two numbers that they give you. So the way we like to write our answer is I usually write an X because that's like my missing side length X. And what I'm saying is that X is between two numbers, okay? And to find those two numbers, you first subtract them. So if I subtract them, that's what's going to go over here. And then if I add them, that's going to be the number that goes over there. So what happens if you subtract 4 and 7? Well, there's a difference of 3, right? If you subtract them. And if you add them, what's the difference? Well, not the difference, but the sum, if you add them, that would be 11. So I know that the third side has to be somewhere between 3 and 11. It cannot include 3 and 11. That's why I don't have the equal mark under there, guys. It has to be strictly between, so strictly greater than and strictly less than on that side. But that's all you have to do. So take a second and you try this one. So what if I give you two sides are 4.1 and 5.7? So if you need to hit pause and get out a calculator, you can, but give this a try and tell me what should go in the blanks. Okay, hopefully you've had enough time to kind of look at it and get out a calculator. If I add them, I get 9.8, so that's going to go over here. And if I subtract them, I get 1.6. So my third side has to be somewhere between 1.6 and 9.8, otherwise it makes a bogus triangle. Okay, and the last example, or something you might be asked to do, is basically just take a picture that I give you and to tell me what kind of triangle it is. So I might label all the sides for you and be like 4, 6, and 8. And then I might just say, what is this? And you're supposed to know, okay, these don't match, right? Nobody matches, so it must be scalene. That's as easy as it gets, in my opinion. You're just, do they match or do they not? And that's how you're going to classify it. Now let's go over and look at the angles. If you need a break, go take a drink of water, or if you need to get your notes pretty, make that happen, and then come back and let's see how this side goes. These are a little more complex. This was the hard part of the self-discovery activity. To classify a triangle, sometimes you can just look at it. Okay, and sometimes you need a rule, and I'm going to write down the rules, okay? So you're supposed to take the sides of your triangle and you're supposed to compare. A squared plus b squared is going to be equal to something, and then c squared is equal to something. Please keep in mind that if you're given 3 sides, c is the biggest side, always. Okay, now I know that this says triangle angles. I get it. It says we're supposed to be talking about angles, and all of a sudden I'm still talking about sides. But you have to use the sides to find out what's true about the angles. And 3 things can happen. If you do the math, this is either going to be equal to, or less than, or greater than. And based on that, you're going to know if it's right, acute, or obtuse. If it's equal to, guys, then it's a right triangle, okay? That's something that you probably remember from the past. This is actually the Pythagorean Theorem. So if you were like, oh, a squared plus b squared equals c squared, you're right, okay? And the triangle is right also. But what if it's not? What if you do the math on a squared plus b squared and you get that it's bigger than c squared? Or if you do the math and you get that it's less than c squared, kind of like our discovery activity, one of them means one and one means the other. So, which one's acute and which one's obtuse? Well, this version would be acute and this version would be obtuse. And if you look at a picture of each of these criteria, I think it will make sense. You would see something where you know, all 3 sides come together and it's a nice little acute triangle. If the c squared is a lot bigger, what that does is it forces an obtuse angle over here. So they're going to look something like this. So if you need a picture of right, acute, and obtuse, please draw that, because sometimes you will just have to look at it and be like, oh, it's this because I see a right angle, or all 3 of those are less than 180, so or not 180, 90, so it's acute. And then of course obtuse is bigger than 90, so that would be how you could classify. These are great. This is my favorite, easiest rule in the world about triangles. The inside angles of a triangle have a sum of what? We should all know this. And if we don't, write it down. It's 180, guys, and that's something that you do in middle school a lot, I think, but we're bringing it back again, and we're going to do a lot more of it now. The inside angles of a triangle have a sum of 180. So we'll do lots of examples in a second to help you out with that. And then exterior angles, I kind of just want to show you a picture of an exterior angle, okay? A triangle maybe looks like this, but if one of the sides of your triangle like shoots out even further and you're like, that looks weird, you're right, that looks weird. But the reason it's shooting out further is because maybe they're asking you, what is the outside of the triangle? You know, the inside, we just said the inside of the triangle adds to 180. So if somebody told you like, this is 60, this is 50, we could find, what does this have to be? Because 60 plus 50, we could add those up. What would that be? 60 plus 50 is 110. And so if the whole thing has to add up to 180, that would have to be 70, right? You would just make sure all three of these add to 180. Yay! But what if then they say, okay, based on this, find the exterior angle. That's what exterior looks like on a picture. It's the outside angle. Well, you have two options, folks. My favorite option is, this is a straight line. And earlier this year, we learned that a linear pair adds up to 180, right? So I would just subtract this from 180. And I'd be like, ooh, it's 130, just by subtracting, just by looking at it. Another thing you could do is there's actually an exterior angle theorem, for those of you that care, that says that the exterior angle is equal to the sum of the opposite angles of the triangle. So like the opposite interior angles, sorry, of the triangle. So what this means is, if you go into the triangle, don't use the one that it touches, but if you use these other two, like on the opposite side, if you add those together, then it will also equal what's on the outside. So you can use a theorem, or you can just look at your picture and do linear pair, but either way you'll get the same answer. It's just doing a little triangle math and grabbing a calculator and making sure things add up on the inside to 180, and then making sure that this straight line also adds up to 180. So let's do some examples. All right, the first example is going to be classify the triangle by the sides. And yes, that's a triangle. Okay, so what if I gave you the sides 3, 6, and 7. Okay, 3, 6, and 7. So this definitely makes a triangle because 3 plus 6 is greater than 7, so yay, it's a legit triangle. Now what I would do is, if I have to classify the triangle, first of all, I know it's scalene, like we said on the last video, it's scalene. Or not last video, but earlier, whatever. And now if I want to know if it's obtuse, acute, or right, obtuse, acute, or right, what I would do is do a squared plus b squared, and then I would do the math on c squared, and then see what that relationship is. Is it equal to, is it greater than, or is it less than? So which one is the c? Well, hopefully you remembered from earlier, the c is always the biggest one. So I'm going to do 7 times 7, so 7 squared. So this is a 49. I'm going to bring down that box of mystery in the middle of like what's going to happen. Now over here I'm going to do 3 squared, so 3 times 3 plus b squared, 6 times 6. And I'm just going to do the math here. So 9 plus 36 is 45. This side is a 49. So which one is bigger? Well, 49 is bigger. And if we look above, if the c squared is bigger, what's going to happen? Well, it's going to be an obtuse triangle. So there you have it. There's one example of how you can use this stuff. Another example might just literally be a picture where I give you this, and maybe I just like give you angles where I'm like, this is 91, this is 35, and then maybe I don't even give you this one over here, okay? So what you're supposed to do is figure out, is this obtuse, acute, or right? Well, if you want, you could find this third angle first, and then you'll have all three to look at. But we should know our answer, because 91 is already bigger than 90 degrees, which means this has to be an obtuse triangle. So you don't really have to find the third side. So that's something that you could do. But if I put a little x or y down here, you could definitely do the math of 180 minus 91 minus 35, and you could find that x. And that would be